broken. So we use Redis as an externalized form of that shared memory for the switches. So the architecture we actually have for Soulmates, it's all hosted in the cloud, which is very nice. We can spin up new systems. And we have Django front ends. They talk to an API that's written in Scala. That talks to MongoDB as our backend data store. We have Solr to do searches and do anything complicated that we would normally do with SQL that Mongo can't handle. We have slaves and masters, etc. for Solr. And we have a Redis on each of the Django front ends. We don't use a single shared Redis. We don't want a single point of failure that would come from that. But that does mean management settings, management switches at the moment can only be set on a per server basis. We could fix that in various ways, but actually the decision at the moment is it's much easier to work with that architecture than to work with a single Redis, just because we don't use Redis enough to really have the management expertise to understand clustering or failover or whatever it is. And there's quite a lot of effort to be involved in actually understanding these things and setting them up in a way that makes the people who have to get woken up at 2 in the morning happy that they're not going to be woken up at 2 in the morning. So normally with the switches we'd use a database, but our Django app doesn't have a database, and I think it's quite unique in that. Most people who use Django use it because the ORM is very nice. It's a very easy way of talking to a database. Our Django app we use purely because the URL dispatching is very nice, very easy to use in Python, and the templating language is really, really nice. If you're a client-side developer, the Django templating language is, as far as I'm concerned, one of the best. Certainly compared to the ones we've looked at that we've used in Java, almost all of them suck. Really do. There is we use Velocity as our main one for the Guardian CMS. It's okay, but in order to get a client-side developer up to using it, takes a couple of weeks for them to understand exactly how we set up the whole system, whereas the Django one's very, very simple. So we use Redis instead. What we do is we have essentially a replacement model. So this is in the source code. We have a Redis models Python script, and it contains a number of switches. So this is health check OK. So we tell it to stop responding to health checks. You can set a switch on the server that says stop responding to health checks, and Amazon's elastic load balancers will take that server out of circulation. Regardless of whether the server is working, it can continue serving requests as per normal. The only thing it stops serving at that point is the health check that the load balancer cares about. We also have the panic switch, which just makes it go, oh crap, everything's broken, and return an error page. And we do that in case there is some significant error that, again, is causing users to take a long time to hit that server. We don't want that kind of failure. We'd much rather people got very quick early failures. We have to initialize the switches, so we have to just make sure they exist, so we save them into the Redis so that they're there. And then the implementation is really, really quite simple. You literally set the state, and then you have a toggle and is on. This is actually quite a bad bit of Python. I don't really like this. This relies on the fact that the state for off is 0 and therefore not truthy in Python. Personally, I would much rather that is on should say if return self state equals state on, rather than just relying on off being 0. But that's because I looked at it today and thought I wouldn't do it that way. But you can see the actual thing is just as simple as a hash set. So we just set the state to X, and when you want to read the state, we just go and get it. That actually happens in superclass here, which scares the crap out of me so much I'm refusing to show you it. So, apologize. I can show you if anybody really wants to look at it. I can show you, but I'm still not entirely sure exactly what all the code does. And I can't believe anybody can have made something so complex to do something so simple. The Redis switches, yeah, very simple. You hit a URL on the server, a certain special management URL that says blah blah off or blah blah status or blah blah on. That switches it. All the processes can check that switch whenever they go to get the value of that switch. It goes to Redis every time. We don't cache it. That ensures that they're up and around. And the Redis process is a local machine, which makes it, we don't cluster them, so you can't accidentally switch off all of the front ends simultaneously. That would probably not be a good idea. Instead, you can turn off 1 or 2 of them, upgrade them, turn them back on, turn off the next level, then turn them back on. And I think, given the high speed, I'm trying to catch up with Simon Willison and his rate of representing, that covers most of where we use Redis at the moment. Does anybody have any questions that I can fail to answer? Yes?
Have you ever faced a problem by maxing out memory usage and key
On the Redises, not at the moment. I would suspect, so the stats, the request per second stuff stores historical data as well as current data. Nobody's looked at it in about a year, but I would imagine the memory usage is creeping up on that as time goes by, and somebody might have to do something about it in a few years' time. But we're not hugely worried about it. Nobody's got any questions for me?
Any more plans to sort of use more Redis, or what's the moving forward?
It's an interesting question. At the moment, we're really on a big Mongo spree. So our lead architect and our platform team lead really like Mongo. So for our data stores at the moment, we're primarily using Mongo. The reason we're doing that is that in most of our use cases, we want a document database. So we are interested in a database that is a full JSON document. A lot of the examples that we've got are for, we deal mostly with content management systems and content that has different fields and so forth. The ability for Mongo to store complex records is quite nice. Simon Willison did most of our Redis stuff, pushed Redis quite hard. And as you can see, most of the stuff that we do is written in Python because Simon was directly involved. On the other hand, the fact that at the moment we use memcached as a cache, there is a desire to have something in between memcached and Mongo, and I think Redis is perfectly suited for a more complex key store, especially with the number of operations that are available. Memcached has a set increment, and my fantastic favourite bit of memcached is that if you do increment decrement, they're unsigned integers. So if you do what I did in one obvious simple case, which was something to be incremented and decremented and start at 0. When you decrement it, nothing happens. It doesn't warn you, it doesn't crash, it doesn't do anything, it just tells you it's now 0, which is quite confusing. So I ended up writing some lovely code that started it at 1 million, and when you got it, deducted the value of 1 million to find out what it was. When you have to build something in 24 hours and it has to go live with a news event, you tend to channel, all those nice architecture things that everyone's supposed to do, you don't bother so much. You get it done. Any other questions? Awesome. I should go play.